Hey everybody, welcome back to Red Seal Garage. So today we've got a couple issues. He has no brake lights, he's got no signal lights, and there's been a long time, what we think is a parasitic draw killing the battery. So if he parks this thing for a week, you come back, the battery's dead. So if he's gonna park it for any amount of time, he leaves the battery disconnected. So I'm gonna show you guys, first off, how to do a parasitic draw test. You need yourself a voltmeter. It doesn't have to be a fancy one, but you want a digital one because it has a high resistance. So parasitic draw test, you don't need the digital one, but if you're getting into testing circuits that relate to anything that's computer controlled, you want a high resistance unit, just like a test light. You want a high resistance unit that uses LEDs if you're doing electrical circuits. I would recommend sticking to one of these if you're gonna do that. Learn how to use them because it protects the circuit. If you put an older style analog meter on there with a needle or a bulb test light that uses an incandescent bulb and you hook that into a computer circuit, what those do is they draw current. They will allow current to flow like a gateway, and they will pull current through a computer circuit and fry something. So you need something that's high resistance. It's like a blockade so that electricity can't flow. High resistance, it's like a gap. The highest resistance you can get is a spark plug. The gap on a spark plug, that is, millions of ohms of resistance, right? It takes a ton of voltage to jump that gap. We're talking 20, 30,000 volts. Okay, I've rattled on enough. Thank you guys for joining and coming back to Red Seal Garage. Let's get into it. All right, so for a parasitic draw test, we're gonna need to disconnect the terminal on the battery. You can do it from the negative terminal. I personally, just force a habit, I've always done them this way. I like to do the parasitic draw test from the positive terminal. Now I know I told you guys in the past, always disconnect your negative first. That way you're not shorting out anywhere, but we're not even bothering to disconnect the negative. We need to keep that circuit connected, so we're just gonna make sure that we're careful with our wrench and we're not touching anything grounded like the chassis when we're undoing the positive terminal. Just be cognizant and just be careful and you won't have an issue. Just gotta understand what's going on. Now what I like to do with these is, if you disconnect the battery on a computer controlled vehicle and then you reconnect it, you're gonna cause all the modules to come alive. They're gonna turn on. And then after a little while, they start to shut down. This vehicle's already been sitting in here for an hour or two, so we know that all the modules should be asleep. So whatever draw is there is gonna be our baseline draw of either something that's staying on for some reason, or it's gonna be below the standard minimum. The standard minimum should be no more than 100 milliamps of current draw from the battery. Fords have their own, it's 50 milliamps. But because industry standard says 100 milliamps is okay, I would say that even if you had somewhere between 60, 70, or 80, or even 90 milliamps, you're okay. If that vehicle's driven on a fairly regular basis, it's not gonna kill the battery. You start getting over 100 milliamps, it's gonna kill the battery. Ford doesn't make batteries, but they do have their own spec at 50 milliamps. It's just the way they like it. But it's okay if you're a bit above 50 milliamps, but you want to be under 100 milliamps. Now, to prevent us from completely disconnecting this battery and reconnecting it and causing all the modules to come alive and then having to wait, because sometimes you might have to wait up to 45 minutes for all the modules to fall asleep. That is also the industry standard, is 45 minutes. So once you're doing a parasitic draw test, you've got to leave your meter on for at least 45 minutes. If 45 minutes passes and you still have a draw, then it's time to start looking for what's causing the draw. So what we're going to do is we're going to put a jumper wire on this on the vehicle's battery cable. Connect up this jumper wire to the bolt threads there. I got another clamp here that'll fit around the battery post. These little alligator clips won't. Hook that on here. Now, what you do is you keep this puppy attached. Don't pull it off the terminal. Keep it touching the whole time. So you can just slide it across. No spark, no nothing. I hook that on. Now we're still connected. So that battery is still connected. Now you take your voltmeter and you want to have it on your 10 amp setting. So go over to on this one, this is an auto ranging, so it has amps and it auto ranges, but it does have a 10 amp setting, max 10 amp, and then the other setting over here is for milliamps. You want to start on your amps range or else you could blow the fuse inside your meter. So you hook one to the battery cable, and then I'm going to hook the other one over to my clamp that I put on there. Now you can see right now we got 0.046 milliamps. You're allowed 0.1 milliamps, which is 100 milliamps. Right now we're drawing 47 milliamps as a matter of fact, and that's with my jumper on. So now I'm going to remove my jumper wire and see what we're actually drawing here. Hopefully it's not into the amp range. It shouldn't be because it's fairly low. Yeah, so you see we're drawing 207 milliamps. That is double the industry standard. Now I know this vehicle has been sitting in here for a couple of hours, so all the modules should be asleep at this point. So now I'm gonna go inside. And what you wanna do, sorry, I already made this mistake. You should open your doors on the vehicle before you get into this and before you let it sit to allow everything to power down. Open up your doors, use a little screwdriver and latch your door latches. If your vehicle has door pins that turn the bulbs on, you're gonna have to figure out a different way. In some cases you can shut those off. Some cases you might have to put something there to hold those open, or get into the kick panels and disconnect those little buttons inside the door jambs that turn your interior light on, or physically go and open up your interior light and take the bulb out. But in some vehicles it doesn't just turn on the interior light. Sometimes it'll turn on some dash features, like a nav screen or something like that. This thing's old, it's got a stereo in it, and it's an aftermarket stereo. My speculation is it's probably the stereo, but with Fords, in a lot of cases I've run into them having a seatbelt module that stays on. This being a 1995, it was the last year for OBD1. It does have a few modules in it, so something like that could be staying on. It could be an alternator. Now even just while we're sitting here, you can see it's at 209 milliamps. We can unplug the field wires from the alternator, and if it drops, then we know that alternator is causing a draw. And that can happen because they're connected to battery power all the time. Those D terminals are a little bit tough to remove. I'll grab a little screwdriver to help. Ford's kind of weird with some of their connectors. They're not like a thumb release tab. You think they are, but they're actually just designed to be pulled off, but they're still pretty tough. So our draw didn't change. That little bit of movement you saw is nothing. It has nothing to do with me plugging or unplugging the alternator. So basically what you're going to do is, if your doors are latched and they're open, you can access the interior without turning anything on. See, right now, I'm an idiot. I forgot to latch the doors. So the doors are shut. If I go there right now and I open the door, this thing's going to jump up in the milliamps, probably up to maybe even 2, 3, 5 amps, because the interior light's going to turn on. And there is a module or two that might come alive depending on what year the vehicle is and what is energized by those door strikers. So I don't have access to the interior fuse panel right now, unfortunately. But what you're going to do is, you're sitting here, you've got 200 milliamps of draw. You know the vehicle's been sitting for at least 45 minutes with nothing turned on. It's had time for its modules to go to sleep. You're going to go over to your fuse panel, and I always start under the hood anyway. So I need to see the meter, so I'm going to turn it to face myself. I have 200 milliamps, and I'm going to start with the little fuses. That didn't do anything. If it didn't change it, you should be safe to plug it back in. Sometimes you end up screwing yourself by unplugging a fuse and then plugging it back in. So sometimes you might want to leave the fuse out. But if there's no change on the meter, usually you're safe to plug it back in and it shouldn't cause anything to turn on. Now chances are you're going to come across a fuse in here that's going to cause that draw to drop to nothing. I've done all the mini fuses. If I run into a maxi fuse and I take out a maxi fuse and that draw disappears, there is a good chance that that maxi fuse you pulled could be powering part of the fuse box inside the vehicle. So you may not have pinpointed the circuit yet. All you've done is disconnected all the power to the interior fuse box. But since we're out here, we're going to pull these maxi fuses and see which one does it. And I can look up a diagram, or I can look up even just the fuse chart, and it'll tell me what's powered by the fuse that I pulled that caused the drop to disappear. And then what you do is connect it back up and go into the interior, and if there's like 4 or 5 fuses for the circuits that the maxi fuse powered, you go inside the interior and you start pulling those fuses one by one to narrow it down. None of these are causing this draw. So this draw to disappear yet. Last maxi fuse. There it is. So I pulled this 50 amp and everything just dropped out completely. So we're down to 3 milliamps of draw. If I plug that back in, it's probably going to turn live and it'll jump higher, but we'll see. No, okay, so it's just sitting back at the same 209 milliamps. So that fuse number, unfortunately with Fords, they don't give you a description on the lid. That's kind of a pain, because if you don't have the owner's manual, you're not going to be able to look up the fuse that you pulled out unless you go online and look for a diagram, which I'm probably going to have to do because I highly doubt this thing has the manual in it. So what I'm going to do here is I'm just going to look at the lid and see which fuse is that 50 amp that I just pulled. And so that is fuse number 22. Now I have no idea what fuse number 22 is, because on the lid all it says is number 22. Whereas most other manufacturers, I haven't really come across anybody but Ford, most other manufacturers will have a description of what that fuse is for. It'll say, it'll be an abbreviation, so you might have to sort of look up some of the abbreviations if you don't know what the abbreviations mean, but it'll say, you know, like headlights, or could be ABS pump, could be CPU, something like that. In those cases, if you trace it back to a physical module, generally you have to replace the module. Some cases you find out, you know, somebody's got even like something plugged into the cigarette lighter that shouldn't be plugged in. I know that's not the case in this vehicle because I already looked. Those are things to check for first. But yeah, so now we know that the 50 amp, that doesn't narrow anything down for me. So I'm gonna have to go and look that up and find out what that 50 amp powers, fuse number 22, and then go inside the vehicle and start pulling fuses for those circuits. Well, it's our lucky day. This vehicle actually has the owner's manual in it. This is a great piece of information to keep with any vehicle that you own. If you got it, keep it in the vehicle if you can, in the glove box. If you think it's gonna get lost or destroyed, maybe put it somewhere safe. But if you sell the vehicle, please give it to the new owner. These things are great to have around. So I actually made a bit of a mistake there. I thought we had fuse 22. By looking at the lid, it was a little bit confusing. The lid was giving me the impression that the 50 amp was fuse 22, but fuse 22 is at this end of the box. The far end of the box, it's actually fuse number 13. So when I look in here, all it tells me is the 50 amp maxi fuse that I pulled out that caused the drop to go away is for instrument panel fuses 5, 9, and 13. So that 50 amp fuse is supplying power to the instrument panel fuse box to fuses number 5, number 9, and number 13. So we're going to go back, and this is what's called a power distribution box. Inside the vehicle will be a fuse box. That's Ford's terminology. With your vehicle, if you don't have a Ford, it might be a different terminology. Let's just see, there was 5, 9, and 13. Who wants to guess it's 13? Lucky 13, right? So fuse number 5, surprise, surprise, airbag restraint. So again, I was talking about seatbelt modules. Airbag restraint, that 10 amp, that's powering the airbag module. If it's the airbag restraint, we can just take that fuse out. Now the thing isn't going to have airbags and all that, but currently, if that module is staying on for some reason, there's a good chance that the airbag system doesn't function anyway. I would never recommend disabling a supplemental restraint system. I would never recommend disabling a restraint system because I can't. If you want to do it, that's up to you. You know, it's not a good idea to disable these restraint systems, but at the end of the day, if you need the vehicle and you don't have the money to replace an airbag module in a vehicle that's umpteen million years old, right? Not a big deal, okay? So that's fuse number 5. Number 9 is a power point. Now what a power point, that is Ford's nomenclature again. A power point is just a cigarette lighter socket. So that's where you plug in your cell phone or something like that, battery charger, or the actual cigarette lighter. So I better double check and make sure there's nothing plugged in into the power point, but I don't think there is. And then fuse number 13 is your ABS, brake shift interlock, electronic engine control, speed control, stop hazard lamps, stop sense for electronic engine control. So that fuse is doing a lot of things. That fuse number 13, it's a 15 amp. It's supplying power for the anti-lock brakes, the brake shift interlock. So that's when you step on the brake and it allows you to shift from park to drive, neutral, whatever. Unfortunately, it's also supplying power to the engine control module. Probably not all the power. There's probably more than one fuse possibly supplying power to the engine control module, but I could be wrong. This thing is a 1995, so they weren't super complicated. Speed control, now that is probably the cruise control, I'm guessing, when it says speed control. Stop hazard lamps, and that's interesting because the vehicle doesn't have any brake lights functioning, and it doesn't have any functional signal lights either. So there could be a relationship. If the signal light switch or something like that is defective and maybe it's drawing power and at the same time causing the signal lights not to work, that could be a possibility. And then the stop sense for electronic engine control. So what we're going to do is we're now going to eliminate which one of those three fuses is the draw. I'm hoping it's something simple like fuse 5, airbag restraint, because then we can just disconnect that fuse, let the customer know what the situation is, charge him for the time spent on the diagnostic, and he can decide later if he wants to fix it. If it's fuse 13, we've got a whole bunch of secondary circuits off of fuse 13 that we can't just disconnect that fuse. The vehicle won't run, it won't have anti-lock brakes, it won't have speed control probably for the cruise control, if that matters in this case. Depends on what the customer cares about. The brake shift interlock, you won't be able to shift it from park to neutral. So I'm keeping fingers crossed it's not fuse 13, but with my luck it's probably fuse 13. So unfortunately, because I have to open the door, I'm going to turn some modules on, but that's just the way things are. So let's get into the interior fuse panel and figure out which one of these three fuses it is. So I jumped ahead. I didn't bother bringing you guys around to see, but it's pretty straightforward. There's a fuse panel right beside the steering column. As soon as you open the driver's side door, it's right there at the end of the dash. There's a little panel by your knee that says fuses. Pop that lid off. I pulled fuse 5, which was for the airbag restraint system. No change in the draw. Put it back in. Pulled fuse number 9, which was for the power point, which again is just a cigarette lighter socket. No change. And then I pulled fuse 13 and the draw disappeared. So there is one thing that I can eliminate fairly easily. That is the engine control module, because it's right down here. I can unscrew it, disconnect it, and see if that draw goes away. But before I even do that, the other complaint that the vehicle has is it's got no brake lights and no signal lights. Now the signal lights are also on the same circuit as the hazard lights, and fuse number 13 powers the stop and hazard lamps. So I think what I'm going to do is I'm going to diagnose what's going on with those lights. If it's a signal light switch and or also a brake light switch under there, because I highly doubt this thing has 4 burnt out bulbs, and as a matter of fact the customer already checked that. So I'm going to jump ahead, diagnose why those lights don't work and get them functioning, and through that we may fix the draw, because we may have to replace that signal light switch, which could be shorted out internally and causing the draw. But maybe just on a lark, maybe I will, since I got you guys here watching, maybe I will pop that connector off of that CPU just to eliminate it, and then we'll go from there. I think I'm going to do that. So actually I'm going to hook my battery back up to the meter. Okay, we got the battery re-established, so I can hook my meter back up. I'm going to plumb my meter in there. Now what I normally do is I use that jumper wire, and anytime you start messing with circuits, you're going to open the door. To know how much draw you have, you got to disconnect the jumper so all the amperage is being pulled through your meter. But if you say, like I went to go and open the door, before I go and open the door on the vehicle and kick the interior lights on and everything, I put the jumper wire back on so it has another path, so it doesn't blow the fuse in my meter. So we go over to the amp setting. So right now it's showing 35 amps, or sorry, 35 milliamps. I'll disconnect the jumper wire, and then it'll show there's the 209 that we're drawing. I don't know if you guys can see that, but so we got 209 milliamps being drawn right now. I am going to turn this so I can see, and I'm going to undo the connector on the CPU, or the engine control module. It's right down here in the fender. Looks like it's a 10 millimeter. The fabled 10 millimeter socket. Saki Tume baby. Okay, let's just double check. Yes, it is 10 millimeter. Let's get a little ratchet on that baby. Oh, and I should specify, I stand corrected on one thing. This Ford pickup truck, now you may need a magnifying glass to read it, but the cover for the fuse panel inside the truck has the description beside the fuses. I was blown away. I couldn't believe it. So I don't know when they changed that, but I know the power distribution box does not have descriptions for the fuses. You have to consult the manual. But in this case, the fuse panel in the interior does, which is nice. And it does verify that the fuse descriptions in the owner's manual are the same as the descriptions on the cover. Okay, so we got that CPU plug fully disconnected, and we still have a 205 amp draw. It was 209, now it's 205. So the CPU has a, sorry, not amps, milliamps. The CPU has around a 4 milliamp draw. That is minutia. We just eliminated the CPU. That's one thing off of that circuit. And that's all you really got to do, is you unplug things. You start with your fuses, you find the circuit that's got the draw on it. Can be tedious because some vehicles, they've got 75, 100 fuses, and it gets a little tedious pulling them. I always find that the one that turns the draw off is the last one you pull. Okay, so I think now, looking at fuse number 13 again, could be the anti-lock brakes. This vehicle doesn't look like it has ABS. It might be that it doesn't have ABS, right? These descriptions are gonna cover all makes and models of that year. So if you got a 1995 that's fully loaded with ABS, it's in here. If you have a base model 1995 that did not come with ABS, because this was a work truck. This thing was owned by a municipality. It was a like a city vehicle. And those guys, they're gonna order like a work truck with rubber mats, AM radio, no power anything. It's got hand cranks. It doesn't even have air conditioning, as a matter of fact. So we've eliminated anti-lock brakes because it doesn't have it. We eliminated the electronic engine control module because we unplugged it and the draw was still there. Speed control, well, speed control is going to be in the steering column for your cruise control. Now let's see, does this thing even have cruise control? It's a base model truck, so I doubt it. Yeah, there's no cruise. So there is no cruise control. No cruise control whatsoever. So at the end of the day, the only thing we got left is the stop hazard lamps and this stop sense for electronic engine control. So I think I'm going to do what I said before, is I'm going to tackle the issue with the fact that it has no signal lights and no brake lights. And in so doing that, I will probably resolve this draw, because we're going to find out somewhere that there's something maybe shorted, or another light, like this could have a lights module or something like that. I haven't dived into any wiring diagrams. So at this point, I've probably said enough. Let's dig into what's going on. Okay, now first step in diagnosing any electrical fault, if you got a system that's not working, let's say your signal lights don't work, or your brake lights don't work, or your cigarette lighter doesn't work, or your radio won't turn on, always check your fuses first. I've seen this time and time again. Guys in a shop setting, they get ahead of themselves. They start ripping out wiring diagrams. They start chasing, looking around for broken wires, defective components, and all the while they don't have any power to the device that they're trying to diagnose. It doesn't work because they got a blown fuse. Now, a blown fuse is a symptom of something. A lot of people say, well, maybe the fuse was old. There's no such thing. I'm going to tell you right now, and I'm going to say it again. There is no such thing as an old fuse. Unless that fuse has been running at its near maximum, like a 5 amp fuse, and it's running at 4.99 amps for some reason, well, then you got a problem somewhere else, creating a high draw, and you can get a slow burn on a fuse. They'll get discolored. But generally speaking, a rule of thumb, there's no such thing as a bad fuse that went. Fuses are a circuit protection device. Something caused that fuse to blow, and it wasn't the fact that the fuse was in there for 10 years. Okay, so if you have a blown fuse, you can pop another fuse in there. If it pops right away on you, well, now you know you've got a dead short. If that fuse doesn't pop right away, well, now you got to maybe do a little investigating on your harness, see if something's chewed through. You might have an intermittent short. You know, the vehicle's vibrating down a country road and things are shorting out. Or the device that it's powering for some reason has a high draw. And that can happen. So, and before you start using your test light, test your test light. Make sure it works. Because you could be in there for 10 minutes going, oh, I got no power, I got no power. And the bulb's burnt out on your test light. Okay, so first thing I did is I'm looking at the signal lights because those don't work. So we're going to look at the signal lights first. And then we'll move on to brake lights after. Okay, so first thing we're going to do is we're going to see, we're working on signal lights that don't work. I already verified they don't work, and neither do the hazard lights. Now we know the hazard lights are off fuse 13, and we know that fuse has power because when I unplugged it, we had a drop in our parasitic draw. So our next step is to move on to the turn lamps. Now the turn lamps is fuse number 7, and it's a 15 amp fuse. I already pulled that fuse and looked at it. There's nothing wrong with that fuse. Next thing I'm going to do is I'm going to find out if that fuse has power to it. There should be power to both sides of that fuse with the key on. I'll get the key on. Okay, we do have power. Okay, so fuse number 7 has power on both sides. So we know that part of the circuit is good. So more than likely, there's power running up all the way to the switch here, but we have no signal lights. And sometimes you wiggle these and they'll start to work, or they won't. Just depends. So let's kill that noise. Now, I've checked the fuse. Fuse is good. I've checked that the fuse has power, and there's power on both sides. If you have a fuse that's burnt out, you'll have power on one side of the fuse if you got power there, but not the other. So that's something to keep in mind. It's a quick way to check fuses. If you turn your key on and you start touching fuses, and every fuse you touch has power on both sides, that means those fuses are in good shape. They're not burnt out. Now, I know what I'm doing with this test light. I know what circuits can handle being illuminated by a bulb. You do not want to use a bulb test light on a circuit for a computer. If there's a 5 amp fuse in there for the CPU, I'm not going to start probing it with this because this will draw current and it could fry the CPU. So you got to be careful. Chances are it won't when you're testing fuses because it's on the power supply side and not after the device. But it's just a good rule to not do it. You want a high resistance test light, something in the 13,000 ohms range, 20,000 ohms range, so you don't burn those components out. So now that's said and done, we know the next part of the circuit. This thing sends power from the power distribution box to the fuse panel. The fuse panel supplies power to the switch. The switch from there then branches off to the 4 corner lights. We know that there's no power at the lights because they don't turn on, and we know that the bulbs are good. So our next step is now to open up the steering column, remove the garnish, and start probing the connector on the back of the signal light switch and see if we have power there. If we don't have power to that signal light switch, then we got to break in a wire somewhere between the fuse box and the steering column. If there's power there, then I'm going to cheat and I'm going to jump across with a jumper wire from the power to the outputs of the switch where they would supply power to the signal lights. If the lights turn on, then I know it's the switch. It's probably a good guess that the signal light switch is no good. That's a good guess because this thing doesn't have tilt steering. But in some cases, if you have a tilt steering column, and it being the fact that it was a city truck with, you know, probably multiple employees using it in and out of the vehicle all the time, and they're moving that steering column up and down every time they get in and out, they could have broken some wires. Of course, the other side of that coin is rodents. Rodents can get in a vehicle and chew up wires. Other than that, you're very rarely going to find it's the wire. 9 times out of 10, when you have something not working, it's usually the component at the end of the wires. Whether it's a burnt fuse, a switch, or a light bulb, it's usually the component. Let's put this thing down in first. Oh, we're going to have to take the headlight knob off. Pretty straightforward. Pow, they just pop out forwards. It's kind of nice. Oh, we're going to put her back in park. This ignition switch is a little bit janky. Now we got lots of room to work. Oh, right, I forgot about that with Fords. With Fords, to get the upper garnish off, you have to take the ignition switch out. But in this case, it's plastic, it's flexible. I got enough room here that I can unplug. This connector. So this thing's got 2 problems with it. The 4-way flashers do not work, nor do the signal lights. The 4-way flasher switch and the signal lights are all integrated into the same switch. It's called a multi-function switch. It also works the wipers. I think those did work. I don't remember for sure. Let's try it, see if the wipers work. Yeah, the wipers work, but again, there's multiple switches integrated into one. You've got the washer fluid, you've got the wiper switch, you've got the 4-way switch, and the signal light switch. And the signal lights and 4-way switch usually share a common circuit. This one did say stop hazard lamps. Stop hazard lamps are off that number 13 fuse. Now, if it's powering through this, and this is the problem here, we might end up having the brake lights work again. But a lot of times the brake light switch down on the brake pedal is the problem. But we're working on the signal lights first. Now I'm going to have to unbolt this switch from the steering column to be able to unplug it. So there now, we've got our multi-function switch dangling down here. Now we can start playing around and probing through the backside here. Now this is where a wiring diagram does come in handy, because off the top of my head, I don't know which one's power, but it's going to be the fatter wires. We've got a blue with a red trace, and we've got a red with a black trace over here. One of these is going to have power with the key on. I'm just going through and eliminating, trying to figure out which wire is the key power. Well, it's possible if we don't find it, there could be a break in the harness. Okay, there's our key power. So there's our key power. So we know we've got all the juice coming up here. So now what I'm doing, I know I have power to the signal light switch. So now I'm going to signal and see if I get power coming out anywhere. I'm doing process of elimination because I don't have a wiring diagram, so I don't know which ones it is. So I go to each port that isn't the supply from the ignition switch and test right here to see if the switch is putting out anything to the rest of the wires. I've got absolutely nothing coming out of any of these circuits. So we know that all the fuses are good. We know we've got power up to this switch. think I'm going to open up the switch and do a little investigating. See if we can't get it to work, because that will save them some money. If I spend an hour on this thing, it's $80. If the switch is $250, but I can fix it in less than an hour, he's ahead of the game. Okay, so I just got off the phone with the parts store. This switch is $140, and that's my cost. Retail is about $250, but I always give a break to my customers. I don't charge them retail. But if you have a look in here, this is what's referred to as a high current switch. It's all copper contacts, there's no circuit boards, there's nothing lightweight electronic. And it looks like we got some green goo in there. I think that's just the grease that they put in from the factory. It doesn't really look like corrosion, but it could be, because these are copper contacts, and that grease could have absorbed some moisture potentially as it's kind of dried out. So what I'm going to do is I'm going to clean up all of these contacts in here. These are slide contacts, and these, when you move that signal light switch back and forth, that thing slides and it makes contact with all of these plates in here in different positions to function the signal lights. And this is your connection plugs into this for the wiper control. And we knew all that worked, but our problem is in here. So I bet you, now I'm not going to say guaranteed, but I bet you if I get all this cleaned up, put a little fresh dielectric grease on it so everything slides nice and doesn't wear out, this will probably work. I'd probably charge him for the amount of time it's going to take me to open this up, clean it up, put it back together, half an hour. So he's looking at $40 as opposed to like I would probably sell him the new switch, because I'd have to go get it. It's $140 to me plus tax. I'd probably sell it to him for $175. I make a little change on the parts. That's just life. But retail's $250, so I get a little change, he gets a break, everybody's happy. But instead, if I can get this thing to work, and I'm kind of trying this on a lark. If this doesn't work, I'm not going to charge him labor on this. If it goes back together and it works, I'm going to charge him probably a half an hour, $40. So everybody be ahead of the game. And I put $40 into my pocket instead of $20, $30 on a part. Use a little brake clean here. I'm going to give everything a little wipe down here and see. Get most of that grease off before we hit it with some red Scotch-Brite. So we can actually see there, once I got all that grease off, there's discoloration on the plate. So that looks to me like there had been some moisture in here. Could have been just condensation. So I'm fairly confident, because this is just all high contact stuff, right? This is all, high current contact stuff. So the high current flows right through these plates. All modern vehicles these days, their switches are what's referred to as discrete inputs. So when you flick a switch on the dash, or you move a lever for any kind of device, whether you're turning on wipers or moving a window up and down, the switch that you're controlling is a low current switch, very low current, sends power over to a relay, which is in itself an electronic switch, and then the relay will control the high current side. But this is old school. There is no relays involved in this. This has 12 volts coming in from the battery. It's got another 12 volts coming in from another spot from the ignition key. And anything you do here, these are knife switches. This is high current, things moving, sparks flying. And that is why you clean this up, you got to put dielectric grease back in it. If you don't, you're going to blacken these contacts from the sparking and the arcing, because that's what happens in there. When those cross over the gaps, they're going to have a little bit of a spark. You see how nice those copper contacts are coming out? And the stainless steel brush, it's nice because it doesn't remove any material. You can use the Scotch-Brite, but use a worn out one. Don't use a brand new one, because you start removing material, and we don't want to remove any material. Okay, that's nice and clean now. Now the other thing we got to deal with is the four-way switch. Look at all the green monster in there. That's Green Monster, guys. You're seeing her firsthand here, behind the scenes of the horror flick, Green Monster. Okay, dielectric grease right here. Synthetic dielectric grease. Brake lubricant, easy slide. Hey, guess what? This works for more than just using it on brake slider pins. Synthetic dielectric grease, that's what you want. You're going to take a little bit, and you don't need a ton of this stuff, ladies and gentlemen, just a skim coat. What this does is it protects all these little electrical tabs from corrosion. And at the same time, lubricates everything as it slides when things are moving across the plates. You want to go over the whole plate, not just the little buttons that stick up, because you want to prevent corrosion on these components. Be careful when you take stuff like this apart. There's, in a lot of cases, spring-loaded components, and you might get yourself in some trouble if it just pops apart, right? All these little plates have springs behind them. If you go yanking it apart, not paying attention, these plates could fall, and now you're playing pickup sticks and trying to figure out where the springs go and which plate goes where. But yeah, it looks like everything works in this. Let's plug it in, see what happens. All right, we got our brand new switch, fully custom rebuilt. Let's actually just plug it in first. Okay, something weird there. That wasn't on earlier. Our high beam indicator light is on, and our lights are on, but our headlight switch is off. And then when I pull the switch out to turn the headlights on, that light goes off. Our high beams are powered right now for some reason. Okay, I think I'm gonna have to pull this switch apart one more time. But anyway, let's test on this switch here and see if the signal lights work. Okay, so doesn't look like. I guess it wasn't the switch. Great. But now when I plug it in, the high beams are on. Those work. Okay, we got to take this apart one more time. Find out what we did, because before I took it apart and cleaned it, my high beams were not on, and now my high beams are on, and the other problems still exist. The signal lights still don't work, so maybe something popped out of position when I was putting her back together. I'm just gonna have to find out. All right.
All right, guys. I had to jump a little bit ahead on this F-150. Last I was dealing with the signal switch. I took it apart, cleaned it up, plugged it back in, figured that would work. Then we had the the high beams on constantly. So I took it apart again, found out that one of the little contacts was out of position in it, reworked the switch again, cleaned it up, double checked everything, put it back in. We still have no signal lights, we still have no four-ways. But when I jumper at the connector, I can disconnect the plug from the back of it and jumper it. Then I end up getting the lights to work. So I'm just going to show you here real quick. As you can see, this is snowballed drastically. We got the steering column out. There's a bracing plate that goes in the back I had to remove so I could get to the harness, because, and this is that plate I'm talking about here, and the steering column, because the main harness that runs into the dash from the firewall runs in behind that plate. Now that's the main harness, big tree trunk of harness right there, and it branches off into the fuse box, the ignition switch connector, and down here we have the connectors that go to the back of the signal light switch. Now what I was seeing in there, and the reason I had to go this far, is I even at one point got a new switch just to settle my mind, because I'm seeing taped sections of wire here. We've got melted wires in here. I don't know if you guys can see that. There's a melted wire. There's melted wires on the back of the fuse box. These wires go to the four-way flasher, and we have melted wires on the brake light switch here. This is the connector for the brake light switch, and you can see those wires were melted and have already been replaced. But where these branch off into the harness up here, there's a whole bunch of melted stuff, and I could not get to it without tearing this dash apart. Unfortunately, there's just no access to get to these components. So now that I've got this big tree trunk of harness out, I'm going to start opening it up and following back as far as I can go to where we can repair all of the melted wires that we find in here. And it started with me pulling the fuse panel back and finding melted wires on the back of this fuse panel. So, and there's a bunch of janky wires that have been messed around with and taped up on the signal light connector here. This is the signal light connector. So, sorry, this is probably not the greatest view, but we'll get you back a bit here. And you guys can see, that's all the main harness, so we had to gut the dash. So, it's been about a day since the last portion of the video there. I'm gonna move forward, clean up this harness, get it all repaired, get the dash all back together, and then we're gonna plug the old switch back in. I still have the new one just in case, but I don't think there's anything wrong with that old switch at all, because even the new switch, nothing happens. We're gonna get back at it here, and I'll update you guys here shortly. And next you see it, everything will probably be put back together, hopefully, and working. All right, so 11.7 million years later, we finally got this truck solved. We had no signal lights, no brake lights, no four-way flashers, and there was a parasitic draw. So we started with the parasitic draw in the beginning. So let's have a look and see where we're at with that. Just grab a light here. So as you can see, we're connected up to the battery here. We got the battery disconnected. We're jumped across with our voltmeter set on a 10 amp scale, and we're drawing 5 milliamps. Industry standard, like I mentioned earlier, is 100 milliamps. Ford's standard is 50 milliamps. 5 milliamps is great. So we found a few things. You know, there was a fuse missing for the DRLs over here in the battery junction box. We replaced that fuse, and what I noticed is that when the DRLs are on, some of the signal lights would come on. Through the course of digging into the wiring behind the fuse panel here, as you guys can see, the fuse panel here, this is the one we were dealing with. Now in the back, I saw a couple melted wires for the four-way flasher. This flasher here is for the signal lights. There's one in behind that's for the four-way flashers. The wires were melted to that. Wires going to the brake light switch were melted. And actually, this truck, you could put it in gear with just the key on, which you shouldn't be able to. You should have to step on the brake. So I ended up tearing the whole dash apart. You saw that. I mean, I didn't show you all the steps because it would be a very long video. Probably quite boring because you would have just saw me laying inside this truck for literally hours, just cutting out bad wires, replacing all the burnt wires in the harness after I cut the harness open. And if you guys are wondering, one of the best tools you can use to open up a harness and cut the tape off is a seam ripper. You can get them at a sewing store. I bought one off the Snap-on truck because it's a Snap-on one. You know, I'm probably not going to be caught dead in a sewing store, but I bet you they're cheaper. So yeah, we got it all back together. You can see the draw is down to 5 milliamps, which is perfect. And over here, you can see our cluster of melted licorice. All these wires I had to cut out of the harness. It doesn't look like much, but when you're dealing with a harness that has about 150 wires, maybe 200 wires in it, digging through and getting into the middle of the cluster to find everything that's melted and fused together takes some time. You know, we're dealing with roughly a 3-foot section of harness that goes from the inside of the firewall, from these bulkhead connectors here underneath the brake booster, but on the inside, running up and branching off into the dash. We had to slice it all open, dig through it, find all the bad wires. Now this was a problem that was built in to the vehicle by somebody screwing around with it. It's not a problem with the vehicle itself. This was a city truck, and they had a natural gas system on it. They probably had an alarm system on it at one point, I think, because there was wires cut off the ignition switch. So guys, careful what you buy. Stick your head under the dash, see if it's a hog's breakfast under there, because this was a true rat's nest. You know, we got it all cleaned up under there. All the wiring is back to factory. Everything is properly connected with butt connectors and heat shrink tubing. So let's get this parasitic draw meter off of here, my voltmeter, and I'll just show you guys we got everything functioning on this vehicle. Battery's reconnected. Let's close the hood. We know that everything's good and tight. Now, first of all, let's try the four-way flasher switch. See, we got indicators functioning on the dash. We got blinky blinks on both sides in the front. Blinky blinks on both sides in the back. Let's kill the four ways. We're gonna have to turn the key on. Sorry about the key buzzer. This one's exceptionally annoying in this truck. Signal lights blinking. Alright, that's left and right. And as you can see out there, let me turn the key off and on. This is just key on. We have daytime running lights. Look at that. And now, ignition is on. I can't take it out of park. Step on the brake pedal. Now it comes out of park. And our parasitic draw, like I said, is fixed. So guys, even though this actually took real time, I spent a little over 13 hours tearing the dash apart, opening up the harness, taking the steering column out and all the bracketry under there to get at that harness wasn't too bad. It was maybe 2 hours to access the harness. The long process is slicing open the harness, chasing the harness back to wherever it terminates, and then slicing out the bad wires and installing new wires. All said, you know, including right from the beginning, we started with a parasitic draw test. We started going through fuses, finding out what circuit the parasitic draw test was on. It was fuse 13. And then at that point, when I noticed that fuse powered for the four ways, I thought, well, I'm going to stop digging. I did do a couple quick checks. I disconnected the PCM because that was on fuse 13. And that wasn't the problem. But instead of just continuing to dig and dig, I decided, well, let's tackle the lighting issues. Because in doing so, we might cure that parasitic draw, and that was the case. Now, 9 times out of 10, you're going to notice that the electrical failure is usually going to be the component that you're messing with all the time, like the switch. Multifunction switches, they go. And as a matter of fact, our local parts store had one in stock, and that usually tells you something if it's in stock. But that wasn't the case. I cleaned up his old one. There's nothing wrong with it. It turned out that this had a bunch of melted wire because some guys connected something into the harness. They did it the wrong way. They shorted something out. They melted a bunch of wires. The melted wires fused together. Now they're powering each other when they shouldn't be, and that's why we had a parasitic draw. And potentially this thing could have burned to the ground, you know, and it probably stunk real bad when that harness melted because there was a lot of melted insulation and wiring in there. So yeah, guys, thanks for joining me. And remember, when you're buying a vehicle, try and stick your head under that dash because wiring can be one of the most expensive things. So thank you again for joining me at Red Seal Garage. And if you guys have any questions, drop them in the comments. Talk to you later.